Okay, chugging along to number 3. Now we have a situation of an object with a non-zero initial velocity of 10 meters per second heading eastward and a westward acceleration of 4 meters per second squared. Notice in writing up this problem that I have defined eastward as the positive direction. Here's my x0 is equal to 0. Positive is eastward. Negative, therefore, would be westward. That enables me to turn around and say my v sub 0 is in the positive 10 meters per second, and my acceleration being westward is now negative 4 meters per second squared. First question or first subpart of this question asks the velocity at each of the same times that I've been asking before. Again, I'm going to be using that equation, current position, let's try that again. Current velocity is equal to original velocity plus the change in velocity, which is due to the acceleration. So a times t, the elapsed time. Now, unlike the previous problem where I was plugging 0 in for v0, now I'm going to plug plus 10, positive 10 meters per second in for v sub 0, negative 4 meters per second squared in for the acceleration, and of course times as we're going on. Notice that in the first second, our velocity remains eastward at 6 meters per second. So 10, the original, and that is reduced by that westward acceleration of minus 4. Within the second, I remain with an eastward positive velocity. Notice that as I move to 5 seconds, my velocity becomes negative. That means, in sort of a real life understanding of what's going on, that I am now heading westward. My velocity has now turned to 10 meters per second in the westward direction. And if you wished, you could find the time at which my velocity actually dropped to 0, because of course this means that I was originally heading fast eastward, slower, came to a halt, and then reversed direction and started accelerating in the opposite direction. Eventually at 10 seconds winding up at negative 30 meters per second, so that's 30 meters per second in the westward direction, remembering that that negative sign indicates our direction. Why am I asking this crazy question? Now, we don't normally see cars behaving like this, but think about it, and we'll get to this in Thursday's lecture as we looked at objects moving under gravity. This situation of something heading in one direction at a certain speed, going slower and slower, coming to a stop and then reversing direction, is essentially identical to throwing a ball upward under gravity. Ball heads upward at some velocity. Eventually, gravity, which is providing a negative acceleration on it, a downward acceleration on it, causes it to halt. At the top of its arc, velocity is going to equal 0, and then it begins accelerating back downward. And we'll take a more careful look at those problems in class on Thursday. Okay, hopefully that shaking is not too much. I don't actually own a tripod. Certainly nothing like a Steadicam, although probably a Steadicam wouldn't help for that little bit of a tremble. All right, so part B of this question is asking how far the car has gone at each of these time intervals. Once again, we'll use our position equation, same thing we saw before. We're taking x sub 0 as 0. Of course, v sub 0 is not 0. Here it is here at 10 meters per second. You can probably tell from this situation that trying to do this iteratively would really drive you completely insane. And notice that I'm going to assume that you've handled plugging things into this equation just fine. Notice that what these numbers indicate is that in that first second from the starting position, you've gone 8 meters. By the end of the second second, you have gone 12 meters. You may overshoot. Perhaps you've reversed at that point. Oh, wait, we actually can answer that because we see that the velocity at the end of that second second is still positive. So at some point past that 12 meters, you will have come to a halt and started reversing direction. See this 0 meters here. What that means in sort of physical reality is that at 5 seconds, the car has returned to its starting point. And then, of course, once we get to 10 seconds, our car has traveled 100 meters to the west of its starting point.